In FA1-3, we're going to be multiplying and dividing powers with the same bases. And again, the key part of this is it's the same base. So the rules for multiplying and dividing powers is that you must have the same base. So 7 to the power 3 multiplied by 7 to the power 4 is something that we can do. The rule says all we do is when the bases are the same, we can simply add the exponents. Dividing, same idea, but instead of adding the exponents, we can simply subtract the exponents. The bases must be the same. So what are you looking for? You're looking for, can you demonstrate the product rule? Can you demonstrate the quotient rule, which is division? And can you demonstrate when they're both together? So again, the key is demonstrating. You're not just giving an answer, you must show your work. So we'll erase some of this and then we'll enlarge it and we'll get going. So we'll start on some questions on number 4. We'll randomly pick one. Let's pick A. 5 to the power 3 multiplied by 5 to the power 4. Yes, the bases are the same. The rule says when the bases are the same, we can just add the exponents. So we get 5 to the power of 7. Now again, it's asking us to write it as a power. It's not asking us to write it in standard form. So we do not want to put this in standard form. We want to leave it as a power. Be very clear of what they're asking. They want to leave this one as a power, not standard form. Don't put them in the wrong answer type because then the question's wrong. So they're looking for A, can you do the product rule? And B, can you put it in the proper form, standard form, expanded form, exponential form, a power? Just make sure you know what they're asking. So we'll do another one. -7, again in bracket. In this situation, the base is -7 because it's in brackets. Okay, so this entire thing, -7, is the base. So the bases are -7, great. We're multiplying. The rule says when the bases are the same, we can add the exponents. So -7, 3 plus 0, which is -7 to the power of 3. Now, I would personally leave the brackets in, and the reason I would leave the brackets in is because this 3 applies to everything inside the bracket. If you get rid of the brackets and all of a sudden you have this, now that 3 only applies to the 7. It does not apply to the negative, and that's where you can get yourself in trouble. So when you have brackets, such as a question like this, I would highly recommend to leave the brackets. It will make your life a lot easier. So we'll get rid of this and we'll try some number 5. So divisibility rule says, or the quotient rule says that if the bases are the same, we can subtract the exponents. So 8 to the power of 9 divided by 8 to the power of 6. Bases are the same. They're both 8. So we can subtract these and we get 8 to the power of 3, and we're going to leave it as a power. 2 to the power of 12 divided by 2 to the power of 10. The bases are both 2. So the rule says we can subtract the exponents and we get 2 to the power of 2, and I'm going to leave it as a power. Now earlier on we talked about why the 0 rule works. So for example, 7 to the power of 0 gave me 1. This is why it works. 7 to the power of 4 divided by 7 to the power of 4 gives me 7 to the power of 4 minus 4, which is 7 to the power of 0, which is 1. And just like before, we know that any number divided by itself, for example, 5 divided by 5 gives me 1, and 7 to the power of 4 divided by 7 to the power of 4, it's the exact same number, will give me 1. So that's why any number raised to the power of 0 will give me 1, because essentially you're just dividing by itself. And that's the quotient rule here. So let's try another example. Again, it doesn't really matter which one we do, so let's try this one. Negative 6 to the power of 8 divided by negative 6 to the power of 3. Again, the bases are negative 6. I'm going to demonstrate I know what I'm doing by showing my work. And I'm going to leave my answer as a power, and I'm going to leave the brackets in so I don't get confused with the negative sign. Okay, we'll move this up. Try a question here. Again, they're all very much the same. We're going to be using the bases are negative 4 and negative 4. We use the power law for the quotient power law, and we'll just subtract those exponents. Here's something you'll be working on by yourself. Now we'll throw number 8. We'll throw some tougher questions in, and we'll do, for example, let's do C. 6 to the power of 0 multiplied by 6 to the power of 3 divided by 6 to the power of 2. BEDMAS says we do multiplication and division together, left to right. So we starting on the left, we do this part first, and then we do this part. We don't do the division first. You can, it's just you're supposed to go left to right, so let's do that. 6. Okay, I'm going to show my work, and I get 6 to the power of 3 divided by 6 to the power of 2, which is the same as 6, 3 minus 2, because I can subtract that, which is 6 to the power of 1. Again, I'm going to leave it as a power. So make sure you are demonstrating that you can actually show all your work and you're using the rules. You're not just using a calculator. You're not putting it in a standard form. You're leaving it as a power. The question asks you to leave it as a power. What you don't want to do, and I've seen this many times before, for example here, is they go 4 to the power of 3, which is 64. And I'm going to multiply that by whatever I get from 4 to the power of 5. And then I'm going to divide that by 4 times 4, which is 16, multiplied by, and they're using all this standard form when really it's as simple as just using the power rules and leaving it as a single power. It will save you a lot of time, and the question specifically asks you for a power, so do not give standard form. I'm going to flip to the next page now. So on this page here, we're just dealing with pretty much the same thing. We're using some adding, subtracting, pretty much all of the rules. Remember what they're looking for. They're looking for can you use both product and quotient rules? Can you do order of operations, so mixing it all together? Can you demonstrate any errors when you have a question such as one of these? And can you solve word problems? So let's go back up here and let's try to work our way through some of these. So we'll pick one. Why not randomly pick D? 10 to the power of 1 plus 10 to the power of 5 multiplied by 10 to the power of 2. Order of operation says I must do multiplication before any adding. So I have 10 to the power of 1 plus 10 to the power of 5 times 10 to the power of 2 is 10 to the 5 plus 2. Rewrite the whole question. Again, you'll have more room than I do. Now, the rule for adding powers is that there is no rule for adding powers. You actually have to go in and you have to just figure out what this is, and then add them together. So 10 to the power of 1 is just 10, plus a 1 with 7 zeros, 1, 2, 3, 4, 5, 6, 7. So that's what? 10 million? And then 10 million plus 1 is 10 million. Sorry, 10 million plus 10. 10 million and 10. Be very careful when you're dealing with these kind of questions, right? You do order of operations always. Questions like here, you can do the bottom part first. When you have a question with a division sign, like a traditional division sign like that, kind of looks like a fraction, you can consider the top and the bottom to be brackets, almost separate questions by themselves. Do those parts first before you start dividing there. So you want to make sure you kind of get this top part done or the bottom part done first. Here you want to do the top part first. Okay, that will save you a lot of stress. Let's erase some of this, and then we'll try something from number 13. Again, they just get more complex. Nothing too much, but a little bit more. Let's pick a random one. Let's do C. It looks like a good one. 4 to the power of 2. Take away 3 to the power of 0 times 3 to the power of 1. There isn't a 1 here, but I put it in anyway because that's what it means, and it will help me later on. It implies that. First things first, I must multiply. Okay, actually, I should probably do all my exponents first. So let's write this out. 16, take away 3 to the power of 0 times 3 to the power of 1 is just 3. Okay, we're going to add the exponent, so 0 plus 1 is 1, so you're going to get 3 to the power of 1, plus 2 times 2 times 2, which is 8, and now I go left to right. 16 minus 3, which is 13, and 13 plus 8 is 31, and there's my standard answer. Now again, evaluate. You could leave it as a product. However, in this situation with adding and subtracting, you really can't. There's no rules to have those kind of products. So you're going to have to convert all of these into standard form because you have your pluses and you have your takeaways and your subtractions. And so make sure you're putting all these into standard form. Now these ones are very tricky. You look at E. You're going to want to do this bracket first, then multiply by a negative 2 to the power of 4. Now all the bases are negative 2. So this will work. You can use the quotient rule. You can use the product rule here. After you're done all of that, you're going to get a standard answer. Then you will add whatever the standard answer to negative 2 times negative 2 times negative 2 times negative 2 is. You'll add those together. There are no rules to combine those. Standard form and standard form. So this is one question here, and this is the second question here. When you're done with that, you're going to add them together at the end. So be very careful when you're dealing with these. Here, you're going to go left to right until you get up to here. Then you're going to add whatever you get from here. So again, you have two different questions here. Whatever you get from the answer for those two, you're going to add them. So just be cautious there. I'll try to erase some of this. So again, here you're looking for errors. You're looking for order of operation errors. You're looking for laws of exponents errors. Did they add when they're doing multiplication, or did they multiply? So the rule says when you're multiplying bases or powers and the bases are the same, you add the exponents. The quotient rule says when you're dividing powers and the bases are the same, you subtract. So make sure when you're going through it, you're looking for those basic rules. Did they add accidentally, or so did they multiply the powers accidentally? Or did they add the exponents properly? So just be careful when you're looking through them that you're kind of in the back of your mind thinking about the rules. And then here, can you just do a word problem? My advice to you is it's going to fit into one of the division rules or the multiplication rules. So it's out of the product or the quotient rules. So you just kind of have to look through it, rationalize which one makes more sense, and then apply that logic. I don't want to kind of give you the answer on all of those. So that is worksheet 3. Hopefully that helped. And if there are any more questions, feel free to ask. I'm always here to help you. So good luck.